So we saw in the last short video that, in fact, the simple fact that in science we often have to rely on consequence, the observation of consequence rather than antecedents, poses a problem because it means that whenever we are affirming a consequent through observation, it actually gives us no certainty that our antecedent is correct. And this shows up all over the place. So consider this. One of the ways, and I gave you this argument in class, one of the ways we know Earth is a sphere is because we observe different stars in different places. If we put that into an if-then format, then what we're arguing is if the Earth is a sphere, then we will observe different stars in different places. And again, the antecedent is sphere, the consequent is different stars in different places. It's not the other way around because simply observing different stars in different places doesn't somehow make the Earth into a sphere. But if the Earth is a sphere, then we will observe different stars in different places. Yes, we do observe different stars in different places. We have affirmed the consequent, and can we therefore conclude that the Earth is a sphere? Logically, we cannot. What if it's some other shape? What if the sky is moving in a certain way that we don't understand? There are other possible reasons that we could imagine why we might see different stars in different places. So in fact, the conclusion is invalid. We've committed a logical fallacy, and the argument as it stands gives us 0% certainty that the Earth is a sphere. Maybe not quite zero, but we'll come back to that. How about this? The fact that stars show parallax is proof that the Earth orbits the sun. Well, again, an if-then format, if the Earth orbits the sun, then we will observe parallax of stars. We affirm the consequent. Yes, we observe parallax of stars. And therefore, we invalidly conclude that the Earth orbits the sun. Here's another example we talked about in class. Edwin Hubble knew that he had found a Cepheid variable in the Andromeda Nebula when he observed its characteristic shark fin light curve. If the Andromeda nova is really a Cepheid, then it will show a shark fin light curve. Yes, the nova shows a shark fin light curve, thought Hubble, therefore the nova is really a Cepheid. But that is a logical fallacy of affirming the consequent. We know the sun contains hydrogen because its spectrum shows a line at 656.3 nanometers. If the sun contains hydrogen, then it will show a spectral line at 656.3 nanometers. Yes, the sun shows a spectral line at 656.3 nanometers. Therefore, the sun contains hydrogen. Well, what if there's something else that produces spectral lines at 656.3 nanometers? Even our calculations, remember I told you that calculations are a form of deductive reasoning. Alpha Centauri's parallax shift of 0.76 arc seconds allows us to determine that it is 1.32 parsecs away. The argument goes this way. If Alpha Centauri is 1.32 parsecs away, then it will have a parallax shift of 0.76 arc seconds. Yes, it has a parallax shift of 0.76 arc seconds, therefore it is 1.32 parsecs away. Again, we have affirmed the consequent and drawn an invalid conclusion with no real certainty to it. To give you one more example, consider the question that's debated between people who believe in evolution versus creationists who believe that God created the earth in a literal 6 days. Well, here's an argument that you will get if you take a biology class and study evolution. One of the pieces of evidence given in favor of evolution is this. If vertebrates evolved from a common ancestor, then they will have similar structural features. Yes, they have similar structural features, as we can see in the bones of the human arm and hand, the lizard arm and hand, the whale fin, the bat wing, and so on. So you will be told that therefore this is proof that they evolved from a common ancestor. But if you put this argument into this if-then format and identify the antecedent and the consequent, you understand that in fact this is a logical fallacy. We are trying to prove the antecedent by affirming the consequent, and that is logically invalid. And to show you how invalid, let me make exactly the same argument, but change the antecedent. A creationist might argue, if vertebrates were created by the same designer, the same mind, the mind of God, then they will have similar structural features. In the same way that an engineer designing different types of cars, all the cars will have similar features. Well, yes, this person could argue they have similar structural features, and therefore this is proof that they were all designed by the same mind of God. It's exactly the same argument, but because it's affirming the consequent and therefore logically invalid, it can be used to support either position equally well. So this takes us not to Batman's dark secret, but science's dark secret. And that is this, that scientific claims, because we rely so much on observing the consequent rather than the antecedent, scientific claims can be disproven 100% with 100% certainty if we deny the consequent. But if we affirm the consequent, then we actually have not proven the scientific claim. We're actually giving it virtually no real certainty to that particular argument, that particular claim. So almost all the scientific arguments you have ever been given in your time in school have all employed this logical fallacy of affirming the consequent, which gives us no real certainty about the truth of the scientific idea we're arguing. Now, does that mean that science is all bogus? Obviously not. There is a solution, and we will take that up in the next lesson. Let me just give you a little preview for the solution to this problem. The same way that scientists solved the problems with empiricism, we have solved the problems with rationalism, and here is a quick summary of the solution. It goes this way: 0 plus 0 plus 0 plus 0 plus 0 equals 85. I will leave you to think about that.